Good morning. Jon and I just wrapped up our Q1 2024 earnings call, and we wanted to take a few minutes to address some of the questions that came in through Twitter. So with that, we'll go ahead and dive in. One of the great questions and one of the things we highlighted on today's earnings call was around our partnership with Biotech. So from Hyliion, for the recent partnership with H2Bio, which is Biotech, how is this collaboration going to benefit both companies? Please elaborate more on this. So Biotech is a producer of hydrogen production facilities. They also are in the transport of hydrogen. One of the unique things with the Carnot generator, it's fuel agnostic. It can run on hydrogen. So some of Biotech's customers are looking for how do they convert that hydrogen into electricity. And some of our customers are interested in running their Carnot generators on hydrogen. And so through this collaboration, we can work jointly together with our customer bases and help solve those problems. Another question that came in was from Tom.Star, and the question was around how much of the stock buyback provision has been used.
So you may remember back late last year, we authorized a $20 million share repurchase program, and we kicked that off late last year, but for the most part, most of the repurchases have happened in the first quarter. So through the first quarter of this year, we repurchased 8.7 million shares for $11.3 million. So that's just a little bit over half of the authorization, and that's through the first quarter of this year.
Terrific. Another question from Arian Allight. Can you talk about your competitive landscape for power generation? Who other than you is making good progress in developing this type of technology? So on today's call, we outlined the 4 markets that we're going after first with the generator. So we've got EV charging, waste gas, prime power application, as well as the marine application. So we've been able to identify customers in all those buckets. We're in discussions with them. Some of them we've already announced LOIs or signed LOIs with them. But those are really the 4 buckets we're going after. There are some others that are in the new tech space, as well as there are the kind of incumbent conventional players who are making more the natural gas diesel engines. We really see the Carnot as it's in a little bit of a league of its own. It is a linear generator technology. There are some other companies doing linear generators, but the Carnot generator is focused on using Stirling engine technology within that linear generator. So that means that we actually use heat to move our generator solution and produce that electricity, which is different than many of the other players out there who are more doing a kind of more of like an internal reaction process to drive their pistons. Our pistons are moved through the expansion of gas, which is driven by heat. So that's where we really see we have a competitive differentiation from the efficiency, the noise levels, the size of the genset, and that's really due to kind of how the system is architected. So parlaying onto that, one of the questions that came in from a Lone Wolf American was, any insights into Hyliion's plans for international markets? You want to take that one?
Sure. So, we think that the Carnot generator, the attributes that make it applicable in the United States are even stronger for international markets. For example, the ability to deliver power where it's needed and unavailable through the traditional grid. It's fuel flexibility. So if you think about markets like in Africa and the Middle East, that a lot of the power is generated from diesel or natural gas, is also very unreliable. We think Carnot could fit very well in those markets. So we do expect to extend our sales efforts into those markets, not right away, but fairly quickly. So stay tuned.
Great. Question from Andreas is, compared to the 120 kilowatt Carnot generator, how is the 200 kilowatt better, and why was the decision made to develop the 200 kilowatt system for customer deployments rather than the 120 with customers while continuing to work on the 200 kilowatt? So for background, for anyone who might be newer to the story, so we are currently running on Dyno our Alpha generator, which is a 125 kilowatt capable genset. It's comprised of 4 shafts. Rough dimensions are it's around 7-8 feet long, a couple of feet tall, a couple of feet wide. Just the 4 shaft solution that has capabilities of 125 kilowatts. We are in the process of bringing forward the beta solution, beta Carnot generator, which in all intents and purposes, it's kind of the same form factor. Really, the sizing didn't change, but we were able to make the system more energy dense, and now that system we expect to be capable of producing up to 200 kilowatts of power. So reason for doing that is a lot of customers look at their adoption cost as a cost per kilowatt. So if we're able to offer more kilowatts of power output in the same size, same footprint, that's a win for the customer. And for us, the greater energy density we can get out of each one of those shafts, the lower kind of adoption cost per kilowatt the customer experiences. Because if we have to make additive parts for 4 shafts, if we can get now 200 kilowatts out of that same sort of size footprint as we were out of 125, that makes the adoption easier for customers. So that was really the driver, which actually leads into another question that came in, which was from Hyliion again, which is, what is the current status of your in-house made linear generator, linear motor, compared to Libertine's? What are the differences? So one of the things is we're moving from that alpha unit to the beta unit. We are insourcing the actual middle part of those shafts, the linear electric motor. So the magnets, the coils, windings, that is now actually going to be designed, developed by Hyliion, as opposed to in the past we were using another company to produce that for us. And so now when you look at the beta version of it, the reactors, the heaters, the cold side, and also now the linear motor are all in-house IP developed by Hyliion. One of the big shifts that we made with this linear generator was moving it from 125 kilowatt capable to that 200 kilowatt capable solution. Another question that came in from Silent Alert was, in 2025, with projections of acquiring more printers and increasing printer speeds, can you comment on how long it takes to print and assemble and manufacture one Carno? So you want to take that one?
So right now we're bringing in several different generations of additive printers from GE, including their most modern and fastest printer. We're also printing new parts, these beta parts that Thomas talked about. They're all different. They're a little bit different than the alpha parts. So we're learning about how long it takes to print each part. There's different materials we're using. Some take longer and some take less time. So it's not a straightforward question to answer, but it's a moving target. But we are making some great progress on getting more production out of the printers that we're bringing in.
Yeah, and then we're on the cusp of receiving the next generation of printer technology from GE as well. I think we're within months of expecting to receive that, so which will then add another increase in speed. But and then one final question here from Dr. Bunsen Honeydew is, can the Carno vary its output from 1 kilowatt to 200 kilowatt, or is it only able to run at a given speed? Can it deal with power demand changes quickly enough, or would it require a battery to cover these spikes and dips in demand in a prime power installation? So great technical question here. So the Carno is able to vary its power levels. One of our actual big unique differentiators is from about a 50% power output, so that would be 100 kilowatts, to that 200 kilowatts power output, we see a very flat or level efficiency of the genset. This is very different than especially like a fuel cell, where it might peak at its efficiency around maybe 60-65% power output, but then at around 100% power output, you've really lost that good efficiency of a fuel cell. With the Carno generator, anywhere from that 50% to 100% power output, we're going to be around that 50% electrical efficiency of the genset. So that's a big differentiator because if you want to run at 150 kilowatts versus 175 or down to 100, the customer is going to still be seeing that strong efficiency. And then in terms of can it respond well to demand changes in demand, it can, and what we're able to do is extract different levels of power generation out of that linear motion of the generator in order to respond to varying power levels. So we expect it to have very good transient response, similar to what you would see of other conventional gensets, as well as it can vary those different power levels, and then the other differentiator is in terms of startup time. So we're expecting to be around 30 seconds until we're actually producing positive power out of the genset once it's kicked on, and then within a few minutes being able to be at that full power output. So as you compare that against some fuel cell technology that it can take upwards of 30 minutes or even more to really get to the full power output, we see the trajectory we're on is a much faster, easier for customers to adopt. So once again, a lot of great questions that came in. Thank you all for submitting these online. This past quarter, we're really focused on development of the beta generator, getting that those components built, getting them into testing and assembly. Second half of this year, the beta generator will be on the dyno and running and testing, and then a lot of work being done on the customer front and building that backlog. One of the things we shared on today's call was that we've identified all the customers for 2024 and where those units will be going to, and now we're at a point where we're actually starting to grow that backlog for next year. So once again, thanks for joining this earnings call, and we look forward to sharing more throughout the quarter.